All right, so I'm going to start with a short introduction. My name is Maor Frankel. I'm a I'm a senior software engineer at Microsoft. I just started a couple of weeks ago, so I'm really excited. I am part of the cyber defense front-end core team there. And before working at Microsoft, I used to work for a few years at Outbrain. And I've been programming for a long time. I've been programming since floppy disks were a thing, so a very long time, and I'm still loving it. And other than being a programmer, I've also got a beautiful family. I've got a beautiful wife and 2 kids, which keep me up at night. And when I'm not programming or spending time with my family, I'm binging on Netflix, or trying to at least. And that's me in a nutshell. And I'm here to talk to you today about making your grandparents happy. So you're probably asking yourself, what do my grandparents have to do with web development, right? Well, unless one of your grandparents is this guy, probably not a lot, right? But our grandparents, like everybody else, probably use the internet. And we'd like to think that their experience of using the internet feels something like this. It is probably closer to something like this. So the reason for that is that our grandparents are what I would define as real users, okay? And as real users, they probably have, a mid-level or old mobile phone or an old computer, right? What do you do when you buy a new phone or computer? What do you do with the old one? You give it to your kids, you give it to your grandparents, you give it to your aunt. And they also probably have, slow or something medium internet connection. And what this means is that the experience that they get using the internet, or specifically our applications, is probably not ideal. And this is very different than how we developers experience our applications, right? Because we use powerful MacBooks or powerful workstations or something similar. And maybe some of us are responsible developers. Maybe we open our dev tools and do a little bit of network throttling or mobile emulation. But, that's inconsistent at best. And that still doesn't give you the real picture of how your real users are experiencing your applications. So what I'm trying to say is that we as developers generally don't accommodate for real users. And so I have to ask, why don't we accommodate for real users? And there's probably 2 reasons for that. The first one would be, maybe you don't care, right? Maybe your target audience are enterprise users, and they also have strong internet connections, and they also have powerful computers, so you think they're not affected by this. And that would be true, that's a good reason, but you got to remember, even enterprise users, sometimes they use your application on the train commuting to work, or sometimes they're, in a coffee shop, on a hotspot trying to use your application. And also, enterprise users usually have a lot of data. So even in those situations, their experience is not going to be ideal. But the other reason I think developers don't accommodate for real users, and I think this is more common, is maybe you don't know, right? Because we as developers, we build our applications, we deploy it to production, it gets shipped up to the user's computer, and it runs on their computer. And we have no idea how it's working on their computer, right? That's completely invisible to us. So we were talking about web applications getting bigger, right? So web applications today are getting bigger, right? They're getting bigger and bigger over time. And I would argue that they also get slower. It's a bit slow. This is a graph from HTTP Archive. And you can see over the course of 9 years, how big web applications have gotten bigger. And this is median, by the way, so the higher percentiles is even larger. But even in median, you can see that mobile applications, specifically mobile web applications, have grown dramatically in size over the 9 years. And even desktop applications have gotten a lot bigger. Now, some of you might say, okay, applications have gotten bigger, but internet speeds are getting better, and computers are getting stronger. And that would be true, but tell us the secret. But the correlation between the size of the application and the improvement in technology is not exactly in correlation, all right? Because here's another nice statistic. You can see the time it has taken the onload event to fire over the course of the last 9 years. And again, this is median, so for the higher percentiles, this is much worse. But desktop computers, not too bad. But mobile web applications have significantly grown in load time over the past 9 years, so 300% increase, that's a lot. And if you're talking about seconds, so a mobile web application is taking almost 17 seconds to load. So think about that, sitting waiting for an application to load for, for 17 seconds. So that was the case for us when I used to work at Outbrain. And we had a new web application. We built it from scratch. It was optimized for performance. We shipped it out to production. Everything was working well. Everybody was happy. But over time, that application started to get bigger, right? We had new developers coming in, introducing new code, new bugs, new tools, and also the data that our users were consuming was getting bigger and bigger over that time. And that meant that our application was getting slower. Now, we were in denial, okay? We did not want to deal with performance issues. We had every excuse in the world, right? You know, it's only on my local host, it's slow. I got a lot of Chrome tabs open. The database has latency, you know, it's not our problem. You know, we wanted to write features, not fix performance issues. And that went on for a while until users started to complain. Now, small point about users complaining, don't ever count on your users complaining about issues with your application, especially performance issues, because a user who's going to encounter performance issues is going to think one of two things. He's going to say, all right, maybe the problem is with my computer, maybe my computer's slow, maybe my internet's slow, or he's going to do the other thing and he's just going to say, you know, whatever, I don't need this, and I'm going to go over to a competitor's website. So don't ever wait for your users to complain. Always be proactive about problems. But in our case, users did complain, and at this point, you know, we had to do something about it. So what do? Well, first course of action, put out the fires, right? We had a lot of performance issues we had to fix. We had a lot of bottlenecks, so we started fixing them. We introduced lazy loading, which significantly improved loading time and performance. So if you're not doing lazy loading, definitely do that. We removed a lot of third-party tools that we didn't need. By the way, again, take a good look at the tools that you're using. A lot of them might not be necessary, especially if they don't have tree shaking. You can even copy-paste the parts that you are using and put them in your application. There's no point in loading half a megabyte of a library just to use a couple of functions. And so we did all of these things, and that, you know, dramatically improved our performance. But like I said, that was good. But we had to ask ourselves, how did we not realize this before? And the better question would be, how do we prevent this from happening again? So at Outbrain, we had a pretty robust monitoring infrastructure put in place. So we decided to look at what we had and see why were we missing these kind of performance issues. And I imagine most people have something similar at their companies. We had availability tests, which are basically health checks that make sure the applications are up and running and our servers are responding. It's very important. If you're not doing that, then please do. But this doesn't give you a lot of insights about how your application is performing, right? We had functionality tests and API monitoring, which made sure our backend services were responding, working properly, even checking the performance on our APIs. But again, that doesn't say very much about how the front end is performing. We also had what you'd call synthetic performance tests, which mean that we had tests that log into our application in internal environments and made sure that they load at a relative decent amount of time. Also, we ran our application through tools like Lighthouse and things like that to see how it performs. And that's also important, and that gives you some insights about performance, but you'll see later that the difference between working in internal environments and your machines is vastly different than what real users experience. So like I said, we were missing something, obviously, and that thing was this. We were missing real data from real users in real time. Okay, we needed to see how our application was performing in the eyes of our client, which really is the only thing that's important. And not only just every client, regular client, but every client out there, because we care about everyone, right? And there's a term for it. It's called rum, not the liquor. And it's short for real-time user monitoring. We didn't invent it. It does exist out there, and quite a few people actually do it. And we realized that this is what we were missing. So, like every developer, we looked for the easiest solution, and we saw, are there any tools out there that we can just plug and play? And there are a few options. Google Analytics gives you some insights about how web applications performance. Raygun, the client-side tracking system, they also have something that gives you those kinds of insights. New Relic browser and SpeedCurve, I heard about yesterday from Dunn's great workshop. They specialize in this. And these are great. You can use them if you want. If you want a quick and fast solution, these are definitely an option. But some of these solutions have, and some of them have more than one problem or even two problems. And those problems are, first of all, most of them cost money, and a lot of money. Except Google Analytics, I think that's free. And even though it's not our money as developers, it's our company's money, but we'd rather them spend it on our salaries, right, and not on third-party tools. But the other problem that some of these tools have is that their definition of performance is very general, right? I mean, how do you define performance in an application? How do you find what's good for you? Because every application is different. So, for instance, Google Analytics have page load statistics that they can give you. And the definition for that is, this is the time it takes a page to load. It begins when navigation begins and ends when the web page has completely loaded in the user's browser. So, I don't know about you, but that doesn't say very much to me. I mean, navigation start, okay, I can get that, but what does it mean the application is completely loaded in the user browser? How do you measure that? So Google Analytics measure it as the load event start compared to the navigation start. So notice that they don't even measure load event end. They measure load event start. But even if they measured load event end, most of us as developers wait for that event to be fired before we actually start doing our work, right? So what good is it for the user that the load event was fired when you still have to wait 4 or 5 seconds watching a preloader before he can start doing his work? So this doesn't say very much about what real users what's important for real users. So we decided to build our own. By the way, I didn't say this, but in our brain we defined a page load as the amount of time it took for the page to start to load until the data was loaded into the user grid, and the user could actually see, we had a dashboard, until the user could actually see his data and start working, because that's what's important for the user. And that was our definition, and that's very different than what you get in a general tool. So we decided to build something of our own. Luckily at Outbrain we had a pretty robust monitoring system already put in place. But I'll show you here that it's not a very complex system. If you don't have something where you work, you can implement something pretty easily. It's not a very complex system. So this was the plan. Your user, in this case, your grandma maybe, would be using the internet, using her favorite browser or everybody's favorite browser. Actually, I work at Microsoft now, so I should probably stop saying that joke. And that browser would run your app application. As that application would be running, it would transmit all the data about performance to a server, just an API that you have on your server somewhere. And that that server would collect all that data and push it into a data store. So at Outbrain we had Prometheus. Prometheus is a free and open source tool. I think it was written by SoundCloud. Like I said, it's free, it's open source. You can just put it into your company, but if you have something else, it'll probably work just the same. Once we had all that data put into our application, into our data store, we can start building our graphs on it. So at Outbrain we used Grafana, again another free and open source tool. And if you don't have something in your company, you can just use Grafana. It works very well. And once we had all the data, we could start building our graphs on Grafana. Now, small tips about Grafana. Grafana also has an alert system, so you can add an alert, for instance, if my page load time increases significantly over a certain period of time, I want to know about it. Give me an alert. So it doesn't have to be just sitting and looking at a screen and waiting to see how performance is going up or down. You can get a kind of push notification out of this. So, like I said, we built all our graphs and we could start seeing, the results. There's one thing that I didn't mention here, and that's how do we actually collect the data from the user's computer, from the application. And for that, we used Web Performance API. Now, I'm not going to get into too much details about it. Dan Shapir gave a great workshop yesterday about it in great detail, and there's also a lot of materials on the internet, so you can read about it, but I'll just go over it a bit, so if you don't know it, you understand the context of what we're talking about. So Web Performance API is defined as the high-resolution time standard defines the performance interface that supports client-side latency measurements within applications. It's a big phrase, but basically what it means, it gives you the ability to measure and access different measurements of parts of your application and how they're performing. And a very naive way of using it, and the basic method that Performance API exposes is the method called now. So the method now gives you a timestamp relative to when the application, the navigation started to load. And you can see that it's a very high resolution timestamp. So most of you probably don't need that kind of high resolution, but for things like animation and things like that, if you want to measure how they're performing, that's quite useful. Also, by the way, due to security issues recently, they started to round those numbers up, so the resolution is a bit lower than what it is here right now. And the idea of using it is you call performance now before a function runs. That function will do whatever it needs to be doing, and when it's finished, you can call performance now again, and the delta between those two calls will tell you how long it took that function to run. And in this case, it's about 500 milliseconds, which is a lot. But you can see how you could do that to measure some kind of function that you have in your application that knows to accept a lot of data, and you want to see how that works with real data for real users in your application. So that's one way of using it. A better way of using it is using markers. So the method marker basically allows you to put a certain marker at a part of your application, and later on you can go back and reference that marker. So you can add these different markers throughout your application where something is interesting to you. If you have a point that's relative and important to your application, you can put a marker there, and later on you can reference that back. So it's also reusable. And once you have those markers put out throughout the application, you can use a method called measure, which will basically give you the delta between those two markers. And that way you can know how long that part of your application took to run. And there's also get entities by name, which gives you all the different markers that you have by a name, or you can also use, it's not here, but you can use get entities by type, which gives you all the different types of the markers you put out there. So that way you can see and measure all the parts that are interesting to you. So that's a little bit about Performance API. Again, you can look at Dan's slides, and they have a lot of information, and again, also a lot of information out there on the internet. Very interesting to read. And this is the example of the index HTML that we had at Outbrain. So we had a performance mark when the index HTML started to load. Now, Performance API gives you better tools to measure these kinds of things, like you can measure from navigation start, which also has things like DNS lookup and things like that that were not relevant for us. But it's very flexible, and you can put it wherever you want, or you can access things like request end exactly when the index HTML arrived, or when the request for the index HTML went out. But we had this to just say, this is where our index HTML started to run. Here's another example of how we used it. We just wrapped our scripts loading in the index HTML, and that basically gave us insights to how our JavaScripts were taking to load. And that was good because we could see, for instance, things like bloat. If that was starting to get bigger, or maybe we had problems with our CDN, we could monitor that and understand that we had a problem. Now, you don't have to do it on things that are synchronous. It doesn't have to be right before a function or a function finishes. You can do it on asynchronous tasks. So at Outbrain, we had a grid that showed a lot of data, and we wanted to know how long that grid actually took to render all that data. So we had a function that took the data source and started to render, and we could call that, had another marker, after that render completed, and we could actually see how long it took the grid to render all its data in production. And again, very different than what we had on our local machines compared to what users had, which was probably significantly a lot more data. So these are just a few examples of how we collected all those markers and added measurements. We measured CSS loading time, scripts loading time, and a total page load time we define as the total page start marker compared to the report's end. So like I said, we were measuring from the beginning of our application start to the point where the grid actually completed the data rendering and removed the preloader, which for our users was what was relevant. So once we had all those measurements counted on the user's application, we wanted to send it back to our server. So two things to note here. First of all, we were also sending connection speed. Now, this is an API that's only available in Chrome, but it gives you the ability to see what was the connection speed when the application was running. And that can give you a lot of insights about how your application is running on different devices or in different kind of scenarios. And another thing to note here is that the last part is Navigator Send Beacon. So if you haven't heard of Send Beacon, it's an API that allows you to send a post request to the server. The only difference between that and other general HTTP requests is that this waits until the browser is idle, or as close to it as it can, before it sends that event out, which means it's not going to interfere with the performance of your application for the user. You can also use just the regular HTTP requests, but it's nice to have. Once we send that data back to the server, we want to have an endpoint that actually takes that data and aggregates that and pushes it into our data store. So there's not much to say about here, just the regular endpoint, taking the data, pushing it in, nothing too complicated. So once we had our markers throughout our application, again, there are a lot more things here that we did, but I'm not going to get into details because I think you get the general concept. We can start putting all of this thing together. So we started pulling our data from our data store and building our graphs on it. So this is the actual graph that we had at Outbrain sitting on a screen where we were working. And this is something that we used to look at every day. And I'll go over a few of the metrics that we used to look at just to give you an idea. There are others here, but these are enough to give you kind of a general idea. So the first one, and probably most important, is average page load time. This tells you how long it actually took for the user to start, have the ability to interact with your page. And you can see on the right that you can see that trend over time. So you can see if we're getting better or worse, and respond according to that. So CSS load by browser, you can see how long it took for the CSS to load. Prescripts load by browser. This is an interesting one. At Outbrain, we had Google Tag Manager in our application. And what Google Tag Manager did is allow our guys for marketing to inject scripts into our application, certain tools that they used for marketing. And that's very good because that means that we as developers didn't have to do any work. They were completely free to do whatever they wanted to do. But the problem with that was that we had no idea what was going on. And a lot of times they pushed things in that hurt our application's performance, and we didn't know about it until somebody complained. And in this case, we could actually see when they made these changes. So you can see the little spike there at the beginning. That was some kind of tool that one of the marketers put in which hurt performance. And with this, we could actually go and say, hey, do you really need this JavaScript or this tool because it's hurting our performance? And in this case, they didn't need it. They removed it, and it went back to normal. Scripts load by browser. Again, you can see that that's what we saw before, just how long it takes for our JavaScripts to load. And an interesting one is Angular load by browser. So Angular load by browser, like I said, you can measure things that are asynchronous. We wanted to know how long it took for Angular to bootstrap and render all its components. And you can see here it's very significant, and that helped us to really kind of make optimizations to this framework, which before we had no idea how long was that part of our page load time. One more interesting breakdown is by country. This is very interesting because you can see there's a huge variations with how the application works in different countries. And this can help you, for instance, maybe you have a problem with your CDN configuration and things like that, so you can start doing optimizations on that. Again, before that we had no idea. And we also monitored the file size of our application, so we could see if we are starting to get bloat and the application was getting bigger, maybe it's time to start breaking that apart. So these are all the kinds of different metrics that we use to look at. Again, there's more, but these are the main ones. But there are also a lot of breakdowns that you can do using Grafana, and it's very interesting. The first one is, you see we have a little checkbox up there that we can kind of see the deployments of our application. So we could actually see when a deployment happened and what effect that had on the performance of our application. So if we had somebody pushed in bad code, we could see, okay, somebody did a bad deployment. Let's go back and see what was the problem. So we had a very good correlation for how we were doing our work. And you can see the little spikes after each deployment. That's a cache miss. So you have a little bit of a spike, and then cache kind of settles down. So you have to give it a bit of time to really see the effect. And that you can see that through all the different graphs. You can see that. Another breakdown is by browser. Okay, so we could see how our application was working on different browsers. In this case, it's Firefox. And this is very interesting because Firefox is considered to be a pretty good browser, at least good as Chrome, or some people might say even better. But you can see that there's a big difference between Firefox, which is about 7.5 seconds load time, and Chrome, which is 5.8. Why is that such a big difference? Because these are basically two similar browsers as far as performance is concerned. And the only difference was that we developed on Chrome. Okay, so we were not accommodating for users that were using Firefox. And that was enough to make a 2-second difference between loading time. So you can see how much of a difference it makes on what you're developing on and what your users are using. Another breakdown is that you can have by percentile. So generally this is the percentile that we used to look at, the 75 percentile. Because the 50 percentile means that 50% of your users are getting an experience worse than what we saw. And if you don't care about 50% of your users, then maybe your business model is not going to work very well. And you can see again the huge difference. So 50 percentile was about 5-point-something seconds, and this is 11.5 seconds. So the variations of how your application is performing for your users is vast. It's huge. There's a lot of difference. So you need to kind of look at everybody and not just the ones that are performing well. And like I said before, you can also break down by connection speed. And again, you can see here that somebody who's working on a 3G internet connection and is part of the 75 percentile is waiting almost 24 seconds for our application to load. I don't know how many users are going to wait for 23 seconds for their application to load. A lot of them might just say what I said, just move on to a competitor. And again, you can see the huge variations when these kind of different statistics come into play. The last interesting breakdown is we had a breakdown by environment. Right? We had internal environments at Outbrain that we used for testing and kind of QA. So our internal environment was simulator. And this is again 4G 75 percentile. We saw before that was about 11.5 seconds. So an internal environment is 7.1 seconds. Again, a huge difference. So what I said about synthetic tests that log into your application and kind of see the performance, they're not giving you the real picture. I mean, it's good for, kind of stopping major changes that are going to break the application's performance, but it's not enough to give you a real picture of performance. So those were all the different kind of views we had and breakdowns. Like I said, there are more, but these are enough for you to understand how this works. And again, this is something you can customize and you can fit to what's interesting to you. If you don't look at slow internet connections, you don't have to look at that breakdown. If you don't care about 50% of your users, then you don't have to look at them. But like everything, there are a few things that you got to keep in mind when trying to implement this kind of solution. The first one is noise. Okay? you're talking about data that's coming from real users, and that's a lot of data, and that includes a lot of noise, right? Because maybe a user just opened your application and went into a tunnel, or maybe there was a runtime error, a JavaScript error, which caused the application to load really slow. So you got to start fine-tuning that, and it takes a little bit of time until you get to the point where your measurements are exactly what's interesting to you, and you kind of reduce that noise and really see the real picture. So that's something that you got to keep in mind. One more thing is that we're talking about big data, okay? So at Outbrain, our application had a few 10,000 users, but our widget team had implemented this, and they had hundreds of millions of users. And all those users were sending data back to the server. That's a lot of data. So you have to know how to handle that. So at our widget team, for instance, we did sampling. We took 1 out of 10,000 users and looked at their data. So you don't, and that's enough to give you a picture. But again, it's a lot of data. You have to keep that in mind, and you have to know how to handle that. One thing, a little bonus, that I didn't put in the other slides because we didn't actually get to implement it while I was at Outbrain, but I think it's very interesting, and it's something that you might want to consider, at least trying to play around with it. Tracking memory leaks. So tracking memory leaks is a very big problem, right? Because memory leaks happen over time, and we as developers refresh our browsers about every 5 seconds, right? And not only that, they're very hard to reproduce. So we don't know usually when there's memory leaks. We're pretty blind to this kind of problem. So Performance API also exposes an API called, a method called memory. It's a property actually. It's available only on Chrome, and it has a few issues, and I'll talk about them. But for what it actually gives you, it gives you a snapshot of the memory. And it gives you 3 properties: the JavaScript heap size limit, which is the upper limit of how much heap can be allocated to your application. The other property is total JavaScript heap size, which is the actual heap size that your application has available, including empty space. And use JavaScript heap size, which is the total amount of heap size that your application is using, all the objects and everything there. Now, there's a couple of problems with this. The first one is these numbers are bucketed in 5 megabytes buckets, so you're not getting a very high resolution here, but I think 5 megabytes is enough to kind of understand what's going on. The other problem is that the render process, which actually has the memory, can be shared by a few tabs. So you're not always getting the memory of your specific application. It could be other applications together. So it's not always, it doesn't give you the real picture. But I think it's enough to kind of get an understanding, especially over time. And there's probably a couple of ways that we thought about using it. The first one, you could just send it to the server and start, looking at the data over time. Or you can build it as kind of an alert system. You can say, okay, if, the used JavaScript heap size reaches a certain limit, trigger an alert. And that way I know that maybe my users are experiencing memory leaks. So the guys at Gmail actually used this API to try and understand the problems that they had with memory. I've got a link to that talk here in the slides. You can see it if you want. Gmail, we know, had a lot of problems with performance and memory, and they decided to use this to kind of get a picture of what was going on. So they did something similar to what we did with our monitoring, except they tracked memory. And they tracked the user over a period of 3 days. And you can see here on the left that the memory of the application over the 3 days increased dramatically, especially for a tool like Gmail, which is open for a few days, sometimes open for 3 days straight. You can see that the memory increases. And when the memory increases, you can see also the latencies in the client-side application gets more frequent. And you can see how memory leaks affect performance. And they did this, and they could actually see how memory was affecting their performance. And this is the graph of when they started to implement their solutions, and you can see how high memory was for the 95, 99 percentile. And when they started implementing the fix, they could actually see a reduction in that. So this was something that was very useful to them. Again, it's not something that we had a chance to implement at Outbrain, but something that you maybe want to think about, especially if this is a problem that you're dealing with. So success. At least, that's what we felt at Outbrain. So the few things that we felt, this really helped and improved our workflow. First of all, it actually reduced our load time from almost 20 seconds to about 9 seconds. That's the 75 percentile. So that's a huge improvement, and with this we were able to make this consistent, not just, one time. More importantly, this raised developers' awareness, because before we did this, we didn't talk about performance. We didn't think about performance. It wasn't on our mindset. We weren't looking at it. And this really made, especially having this over our heads, really made us think about, performance. We got to deal with this thing. And last, we had a much better correlation between changes and performance issues. Like you saw, we could see when a deployment happened and how that affected. And that has also for negative effects, but also for positive effects. We introduced lazy loading. We could see that number go down, and that really gave us motivation to do better at performance. So a few small things that I like to take from this talk, other than things about performance issues. First of all, if you're not monitoring it, it doesn't exist. Okay? If you don't have some insights about your application and application's problem, you don't know they exist, and you're never going to be able to handle them. So be proactive about these things, and if you think that there might be a problem, monitor it. Dev time is not real time. Okay, so what you think that's working on your computer, everybody likes to say, it's working on my computer, right? Nobody cares. The only place it's supposed to work at is at your client's computer. So remember that. It's very, very important. And last thing is, before you pay for it, try to build it. Now, I'm not saying, you need to reinvent the wheel every time. But a lot of the times, you can build it yourself, and in many of those cases, it's going to be better than some third-party solution out there. Again, it's not always the case, but it's something you need to consider. Sorry, so I know there's no time for questions, but you can grab me after the talk if you have anything that's interesting to you. And that's it for me. Thank you very much for listening.